In this video, we will compare one of the automated processing services with the manual processing by Inflights team. For this, we will use few example datasets that we processed before using the manual processing methods. Let's start our comparison with the most simple output, the orthomosaic. To compare it, we will use a data from the city mapping project that was flown with DJI Phantom 4 Pro with 80% front and side overlap and GSD of 1.6 centimeters. Notice that the pointy objects like traffic light poles create artifacts in the orthomosaic. Another thing is the misaligned white striping on the road. Same thing happens with the tram rails and road barriers. Those lines should be straight. We exported the data from the online processing app in the max detail. We loaded this data into third-party app, as well as Inflights orthomosaic of the same project. Here is the same crossroad with the online drone data processing app orthomosaic on the top. Now let's disable it and enable the Inflights orthomosaic. Huge difference, right? Notice that the tramway rails are straight and the road paint looks much better. As you can see, there are no artifacts and the ortho image is stitched properly. Again, here is the online app orthomosaic. And here is ours. This project is a terrain mapping project with a bit of complicated topography. Here, the main objective was to deliver an accurate topo surface. This dataset consists of 1170 images and 18 ground control points. On our end, we process the data in Pix4D Mapper and post-process the data in various third-party apps. In the online processing software, we exported the outputs in the same coordinate system with the maximum available accuracy. Now let's import them to a third-party application for post-processing drone mapping data. Here we have imported the DTM raster file and orthomosaic. The main objective was to create accurate contours on the ground for the client to use in their CAD software. The online drone data processing app does it automatically, but how accurate are those contours? First, let's check the ground control point accuracy. As you can see, the error between GCPs and drone mapping surface is greater for the online drone data processing platform than it is for Inflights drone mapping surface. But how accurate is the DTM raster file that we exported from the online mapping software? To compare it, we will use our own DTM surface. It was made from DSM from Pix4D Mapper and thoroughly cleaned by our processing team to create a thin surface and later the DTM raster. To show the difference between our DTM and online processing app DTM surface, I created a heat map to visualize the difference. Notice that the app did nothing to remove the vegetation in the project area. The client wouldn't be able to use this surface to accurately calculate the earthwork volume and to do hydrological studies. This DTM surface is non-survey grade. It resembles a standard DSM straight from Agisoft photogrammetry software. Based on this, the online drone data processing app created contour lines. Those contour lines are also on the vegetation. This is unacceptable for serious engineering work. Imagine that you are calculating the earthwork volume for a construction company that will use those calculations to build the earthworks subcontractor. The calculated volume would include those trees. For comparison, here's our thin surface that is survey grade. It can be used by architects and other engineers. Notice that the thin surface runs under the vegetation. Thanks for watching, see you in the next video.